Hello everyone, and welcome to today's webcast, IR Event Log Analysis. My name is Trevor, and I will be moderating this webcast. Today's featured speaker is Hal Pomeranz, Deer Run Associates Digital Forensic Investigator. Please feel free to submit your questions at any point by using the questions window. Hal will be answering them throughout the webcast. Right now, I'd like to turn things over to Hal.
Hey everybody, how's it going? Happy Monday, or whatever time it is, wherever you are. Greetings from Central Florida, where it's currently pissing down rain. But we're all inside and talking forensics on the webcast. So you can see my email address and Twitter contact information if you have questions after the webcast. I haven't been too active on social media lately because, well, I've been spending the last 8 or 9 months doing a lot of IR work for various companies. I'm happy to say that none of those investigations have made the news, unlike some of the bigger, more public ones over the last few months. But generally, you know, our clients like to keep it a little bit under hush-hush, so to speak. But what I've been finding myself doing a lot during those IRs is spending a lot of time with Windows event logs. Now, you know, I mean, when you're doing an investigation, there's lots and lots of different things you could be looking at, right? And some people say, oh, you know, like memory forensics is the way to go, or network forensics is the way to go, or registry forensics is the way to go. That's the, you know, silver bullet that's going to solve all your problems. And I think that, you know, all of those things put together as part of a comprehensive analysis package are good things to do. But even, you know, without those things, I'm finding that I'm getting a really good picture of what's happening in some of these incidents just by looking at, you know, basic stuff like Windows event logs. And so I wanted to pass along some specific areas where I've been finding a lot of gold lately, particular events to look for, particular event logs, and that kind of thing, hoping that it will assist you with your investigations. By the way, if you are interested in, you know, intrusion response kinds of things, I'll be teaching SANS Forensics 508 in Baltimore the first week in March. So if you're looking for something to do pre-St. Patty's Day in Baltimore, come on out to Baltimore. Be a nice small class, lots of, you know, one-on-one kind of conversations going on there. Baltimore is always a good time, so hope to see you there. All right. So, oh, look, we've got the SANS DFIR curriculum. And aside from 508, I also teach the reverse engineering malware class and our new Mac forensic analysis class that Sarah put together, which is an awesome class too, by the way. But we've got lots of other classes and free things like the SANS forensics blog and the SIFT workstation, yada, yada, yada. Right. So what are we talking about here today? We're talking about Windows event logs, which on modern Windows systems live under, you know, Windows System 32 WinEVT logs. We're just going to be talking about the modern event logs from, you know, the EVTX style logs that, you know, started in Vista and later. For 2003 XP vintage machines, of course, they're the EVT logs. There are similar sorts of events in those logs, but I just wanted to focus in on the event IDs and logs from newer Windows systems that you're typically going to deal with, right? And, you know, obviously the logs are in a binary format. You need some sort of special parser to look at them, and there's tons and tons of different event log parsing tools out there, ranging from, you know, Python and Perl libraries so you can write your own scripts to parse event logs. There are command line event viewers from, you know, a variety of different sources, and there's, you know, all the different graphical ones, you know, starting with the Microsoft Event Viewer, but there's also some third-party event log parsers. Me personally, you know, I'll just throw a shout out to Event Log Explorer from FS Pro Labs, which is a nice standalone event log viewer for Windows GUI. Actually, Alyssa Torres pointed me at Event Log Viewer many years ago, and I started using it and really liked it. But, you know, whatever. Pick one that you like. People are always a little bit leery, I think, of event log analysis. I mean, there's a lot of different event logs, and there's a billion different events. They're all mashed up together, and unless somebody sort of shows you, you don't really know what events to look for. But don't be fearful, actually. I mean, there's a lot of good stuff in there, and if you just sit down and start looking at the event logs in the context of an investigation, maybe, like in the context like the super timeline, where you have some other clues, you start to get a notion of, some of the event logs that are important to you, and what you need to be focusing in on. And hopefully this presentation will give you some ideas in that direction as well. Okay, so I'm going to switch off the video so we can all focus on the slides, but I'll be back a little bit later on the video for questions and things like that at the end of the presentation. Okay, so I'm going to actually do a couple of different examples, and these are based on actual incidents that I've investigated in the last, like I said, 8 or 9 months. And so, when you see this one and you think, oh my God, nobody does that anymore. Actually, no. I mean, as recently as late last year, I was investigating a team of attackers who used exactly this tactic for lateral movement. Okay, and it's an oldie but a goodie, but it still works. Okay, so the tactic is, the attacker mounts a file share from, some machine they've already compromised. Typically they're just going to grab, C:, basically, and then they drop their malware somewhere on the disk drive of the target system, and now they have to figure out a way to activate their malware on the target machine. And frankly, the easiest way to do it is by a scheduled task. So from their compromised machine, they schedule a task on the remote system, and their malware starts executing, whatever that happens to be. There are a whole bunch of events that go into this happening, okay, and they're actually events that happen in a couple of different event log files, as we'll see. But basically, at the beginning, there is logging into the target system over the network, okay, and that's, classic Windows event log, 4624 style network login. Now, if typically this is being done as an admin user that they've compromised. So paired with that 4624 login, there's actually a 4672 event which indicates an admin user logging in. And I'll show you the details of these events as we move along through the presentation. So once they've successfully logged into the target system, then they mount the share. And there's an event on the target system that shows that share being mounted. That's good old 5140 in your security event logs. So there's a bunch of stuff in the security event logs around the login and all of that stuff. But there are other event logs as well. And in particular, there are event logs related to scheduled tasks. And there's a whole series of events in the scheduled task event logs that show what the attacker is doing as far as their scheduled task, even if they end up deleting the scheduled task later. You'll still see in the event logs a lot of detail about what was going on with those scheduled tasks. All right, so let's look at this in detail. If you were to put all of the interesting events into a timeline, you might have a timeline that looks a little bit like this, okay? And, if you're just looking at the raw event logs, there's going to be a lot more distracting events going on in the event logs than the ones you see on this, sort of simplified timeline. I'm just trying to pull out and show you the interesting events that you want to focus in on, okay? And like I said, there's a couple of different log files running around for this kind of lateral movement that you want to pay attention to. So obviously, there's the security.evtx log, and that's where you see things, like the network log on and the network share being mounted, and then at the end of the session, them logging off, right? But in the middle, there's all the work they do to actually schedule the task, and that one lives in a separate log file. So there's Microsoft Windows Task Scheduler Operational.evtx, where you find most of the interesting event logs related to Windows tasks, okay, and everything from the task actually being scheduled to being executed, the task finishing and then later the attackers removing the logs. Okay, and if the attackers are using some sort of scripted mechanism for doing this, you'll see these logs come in very rapidly after one another, right? I mean, so they log in, the network share gets mounted, bam, the task gets scheduled, it runs, in the next minute, runs quickly and gets removed, and they're gone within under 10 minutes. So really, it's a very narrow window of time that this stuff can happen in. You don't have to spend a lot of time looking all over the logs for these components, right? So I wanted to drill down on each one of these log entries and show you the kinds of things you can extract from each log message and sort of tell you a little story about what we're seeing in this particular investigation. Right? So first up is the initial network logon. Okay, so this is going to be event ID 4624. You see the login type down there sort of in the middle of the event. That's login type 3, which is the classic Windows network logon that you see preceding a file share being mounted and things like that. Okay, so obviously the event logs are all time-stamped. We'll call this one the St. Valentine's Day Massacre, since it happened on February 14th. All right, so in the event log, you see the user that logged in, right? Names changed to protect the innocent. Okay, I mean, typically this is going to be a compromised account where they've stolen the account credential via some other mechanism. And you see the username and the domain name that user is a member of. You also see the IP address where the network logon is originating from. Okay, so this is the IP address of the compromised machine. And in the investigation, right, so this is the next machine that you work backwards to, get an image of that machine, figure out what happened as you work your way back to patient 0. Okay, so anyway, so you can see who logged in, where from, at what time. So that's what you get out of the 4624 messages, and it's one of the more useful messages, and it starts this whole chain of events. So next up, if the person who was logging in had administrative privileges, that 4624 login is going to be followed up by a 4672 event, which shows that this person is an administrator. Okay, so you see their SID and their username and their domain again. You also see the privilege list, right, which gives you an idea of the different privileges that are allocated to this particular user. The specific privileges, I mean, you could go look at TechNet and figure out what they are, but basically the longer that privilege list vector is, the more power this user has. In this particular investigation that I sort of am borrowing from, this was a domain admin user account that had been compromised and then was being used for lateral movement all around their network. You can see they have quite a large number of different privileges associated with that account. But basically, there are going to be a lot of 4624 events in a typical Windows security log. The ones you want to focus in on are the ones that get followed up by the 4672s, because those are the admin logins, and those are the ones that are going to do the most damage to you, right? So yeah, 4624 followed by 4672, something you need to pay attention to. All right. And then that'll quickly be followed up by that user actually mounting a network share. Okay. So again, you can see the username and the domain name and the SID and all of that stuff, right? It's event ID 5140. That's a network share being mounted. Okay, so you can see, again, the IP address, which is the source of the connection. So this is where they're mounting the share from. And then you can see actually what's being mounted. In this case, they're mounting the C drive. Oh joy, right? And this is, like if you're looking for events that you can plug into your IDS or, your SIM tool for, suspicious kinds of events, I mean, this is the sort of thing that doesn't normally happen in a typical Windows environment, right? You don't see people, mounting the C drive from random workstations all over your networks. This is one where, this is a kind of event that I would look for sort of automated sensors because it's just not that normal, right? So look at, consider the context of the machine, right? What's the source address, what's the target system that's being mounted, and what's the share that's being mounted, right? Because if it's not a file server, why are people mounting shares from the machine, right? So this is one of the things that you can instrument your network to warn you when this kind of lateral movement is happening. But obviously, once it's already happened and you're doing investigations like I'm doing now, this is an interesting event because it tells you something about how the attacker likely put the malware on the system. Right? Okay, they just mounted a network share. Now they can drop whatever they want onto that machine. Okay, so now we've got an attacker. They're using, an owned admin account. They're mounting network shares. A lot of people, they just sort of stop, at this level of analysis. They think, oh, the security event logs, where it's at, and that's everything there is. But there's all kinds of other sort of interesting little event log files that are running around on Windows. And so, for example, you have the scheduled tasks related event logs, and excuse me. So task scheduler operational is the one that has the interesting events. Okay, so right after the network share is mounted, we can see the same owned administrator account registering a scheduled task on the target machine. What's unfortunate about good old event ID 106, scheduled task being registered, is that while it shows the name of the task and it shows the user who registered the task, it does not actually show the source where the task was registered from. And this has actually always been one of my gripes with this particular event was, gosh, I'd really like to see the source IP address where the task was registered from, even if that source IP is loopback 127.0.0.1. I don't know. It's just a source of frustration. You can sort of infer, I think, where the task was registered from. Most likely registered from the same place they mounted the network share, but you can't say for certain unless you have, some network level logging. But there's nothing in the event log that will tell you where the task was registered from. I got a question in the questions window. Is there a good resource out there which recommends audit settings for the security event logs? Which events to audit, event log size, et cetera, et cetera. There are, many are the arguments of wizards. I think there's probably a billion different resources out there that claim to be the be-all and end-all, source for that information. There's some good papers in the SANS reading room, if I remember, that talk about, good settings for event log auditing and things like that. If any of y'all have particular favorite ones that you like, you're certainly welcome to throw them into the chat and share them with the rest of the audience. I don't have one sort of off the top of my head at this point. Mostly because I'm stuck with whatever audit logs I happen to find on the system when I get there. All right, so 106. We've got a scheduled task named @1 that's been registered by our owned domain admin account. Right? So typically, in a IR situation like this, you've got the attacker, trying to move very quickly. So you'll see them scheduling a task in 1 minute, and then that task will run at the top of the next minute. And again, I think this is something where you could easily use this as a indicator for lateral movement in your network, right? A 106 event followed up, within under a minute by a 200 event, which is the task actually running, okay? So now the 200 event is interesting, aside from the fact here that it's happening very quickly, you can see the task name, but it also tells you the name of the thing that's being run by the scheduled task. Okay, so here our attackers were nice enough to name their script malicious.bad. This never happens. I just changed the name of the script to, again, protect the innocent. But at least what you'll see in the 200 event is the thing that got executed, whatever that is. It's often a batch script, but it could be an executable. You may or may not see the full path name to the program depending on where they dropped it in the share that they mounted, right? If they just dropped it in the Windows directory, then they can run it without needing a full path name. If they try to put it somewhere out of the way, then that's better for you because you actually see the full path name of where it got dropped in the 200 event because they have to specify the full path name. Okay, so we've got the task running. You can see the name that's running. And then whenever the task finishes, there'll be a 201 event at the end of all of that, which shows you that it's finished. But in this case, before that 201 event happened, we actually got a bonus, okay? It turns out that in this case, my friends were running a credential dumping tool. It was actually Mimikatz, which they cleverly renamed m.exe. But one of the things about credential dumping tools like that is that they need to elevate privileges in order to, dump the hashes out of the LSAS process or whatever it is they're going to do. So when this particular, malicious.bat ran, it ran the m.exe executable that they had also dropped on the network share. That executable elevated privileges, and you actually get this extra event from the security event logs 4688, which shows the token elevation happening, and it shows you the name of the process that's being executed. So C:\Windows m.exe, as you see here. So that one was a bonus, right? I'm going through my event logs in my timeline. I'm like, oh look, there's the nasty script running, and oh look, there's what the nasty script actually executed. So in my case, I wasn't able to actually go back and get m.exe. It wasn't in the file system, but a little bit of file carving, and hey presto, I can pull back that executable, right? But only because I need to look for it because this extra little security event happened. So that was nice. It's like, oh, okay, great. Thank you for showing me exactly what you're doing on the system. So this was a flat-out credential dump. They moved laterally onto the system in order to try and dump creds, obviously to harvest more accounts so they could continue to move through the network. Right? Okay, and so after their credential dumping tool ran, then we get down to the 201 event, which is the end of the execution. In this case, you'll notice something a little bit different, right? The action name is actually command.exe because they were running a batch script. So malicious.bad is the thing that they executed, and you saw that in the 200 event when the task was started. But since it was a batch script, was actually running was a command shell. So you sometimes see a little discrepancy like that in the 201 output, but that's what's going on here. That's why you get different things in the 200 and 201 events for the action. You actually see the result code of the script. That may or may not be meaningful to you as well. Now, sometimes that's it, right? I mean, sometimes the attackers run their script and they're done. That's good because that means you'll find the @1 job file sitting in the Windows task directory, and you can dump out all the metadata from that job file. In my case, the folks I was working with were a little bit more careful about cleaning up, and so after their task ran, they actually manually removed the task. And when you see a task being removed, that's event ID 141, okay, and you see the task name that's being removed. It's normally going to be removed with system privileges, so you don't actually see anything more than that in the username field. But you can see that you can at least see the task being removed. So these folks cleaned it up, but it doesn't really matter because I know when they scheduled the task, I know what job the task ran, right? So I have all of the interesting data about the task. I don't actually need the @1 job file from the Windows task directory because I got all of the interesting data out of the event logs. And then at some point, you're going to see them logging off, right? I mean, so disconnecting. So again, the login type should, on the 4634 event, should match the login type on the 4624 network logon event, and you'll see the username and the domain name match as well. The log off could actually happen pretty much anywhere in this timeline after they mount the network share. So sometimes I see them logging off, as soon as they've mounted the network share and have deposited their malware on the system, even before they do the scheduled task stuff. So log off events can happen, anywhere in the timeline. Just keep an eye out for them. Nothing particularly interesting unless you're trying to plot exactly when the attackers are logging on and logging off of the system. And in a typical incident, you may see the attacker log in multiple times from multiple different places. Sometimes using different credentials. So you'll see multiple network logins from the same source IP address as they're trying out different credentials, trying to see, which ones have, domain access or whatever access they need to access the data they're looking for. So just by looking at the event logs on this particular system, we actually know a lot about what happened here, right? We see the login event, which tells, which credential they're using, what IP address they're coming from, and, of course, all the events are time-stamped. We have the 4672 event, which says the credential they've stolen is an admin user, and we can see the 5140 event, which shows them mounting the network share from the same source IP address, and what they mounted, in our case, C:. And then you can actually see what they did after that, because we see them registering a scheduled task, right? We see what program the task ran and when it actually executed. You can see when it finished, and you can see that they then later removed the task, okay? So, again, if you're looking for things to plug into your SIM tool or your automated analysis to alert you about this kind of lateral movement, weird 5140 events, tasks being scheduled and then executing shortly thereafter, so like a 106 followed by a 200 within the same 1 minute interval or 2 minute interval, and to some extent cleaning up scheduled tasks. I mean, in my experience looking at Windows event logs, you don't see a lot of 141 events, okay? Mostly people schedule tasks and then let them go. So that might be another interesting one to look for. Okay, so there you go. That's example number one. Basic lateral movement kind of thing, right? We've got we got a URL that showed up in the questions. Let me put it down into the chat here for people. Hold on a sec. Doing a little copying and pasting here. So that URL that I just posted was a suggestion from one of the attendees about places you can go for suggestions on event log auditing and things like that. Okay, so moving on, let's talk a bit about number two, which I call the domain controller of doom. In this case, in this particular investigation, my adversaries were moving around the network using RDP. So there's a lot of malicious RDP activity all over the network. On this particular system that I was investigating, there's the same attack group, but they actually left behind two different remote access Trojans at two different time frames because they'd been in the network for some considerable period of time, and this system had actually been compromised twice. Now, this is a domain controller, and so all of those wonderful security event logs that I was showing you, forget about it. Honestly, a domain controller's security event logs wraps so frequently that there's usually very little usable information, particularly for sort of historical investigations going back more than 8 hours or so. So the problem is, event logs have limited size, right? And so they're circular, and when you fill up the event log buffer, they overwrite the oldest entries. They're constantly eating their own tail like that. And on a domain controller, there are constant security events being racked up by every machine in the domain that's talking to its domain controller. So the security event log on a domain controller spins like a mother, and so you only get a few hours of retroactive logs, usually not enough to show you attacker activity. So we need some other ways to see what's going on the system. So let's see here. What you do get, though, in this case, because the attackers were using RDP, is a couple of different logs related to terminal services. Okay, so there's terminal services remote connection manager and terminal services local session manager. Both logs have interesting events that you want to pay attention to. So the remote connection manager, the interesting log events are the 1149 events. These are, remote connections, remote authentication from various IPs. And in the 1149 events, you can see user and domain and source IP address for the connection, and of course the time that that connection occurred. But if you drill down into the local session manager event logs with that, you also see sort of more detail, okay? So in the local session manager, there are events actually numbered 21 through 25 are the sort of interesting events. But the ones that are particularly interesting are the 21 events. That shows a successful login. So you'll typically see an 1149 event in the remote connection manager log paired with a 21 event in the local session manager log. So they should match up. You should see the same user. You should see the same source IP address. What's interesting is the time stamping on those events. I've actually seen the 21 event, come in, up to a minute after the 1149 event gets logged in the remote connection manager log. And so I assume that, 1149 logs, as soon as the user types in the right password, whereas the 21 event in the local session manager basically shows, the user's desktop being fully instantiated, which is why there's a time gap there. So other events, you can see when they log off. So that's a 23 event. And there's also a disconnect event, which typically happens a few seconds after the log off event. So you'll see this pattern: 1149, 21, 23, 24. And you can see how long the session lasted because it's the time frame between the 1149 event and the 24 event. So if you're trying to build again a map of user login and log off activity, you'll see that. Okay? So this is the simplest possible case. They log in, they do something for a little while, they log off. Right? But where this gets more complicated is that you can actually see situations like this where, in this case, they were using the same compromised credential, but they're actually logging in from two different systems, right? So at 1500, you see the 1149 event, which is them logging in from, in this case, 192.168.1.10. And you can see the 21 event, which shows that logon, being successful. Then a little bit later, you actually see them logging in from a different IP address, right? So notice the 1149 event that's happening at 1600 comes from a completely different IP. Now, typically when that happens, right, if you're logging in as the same user but from a different IP, the current session gets kicked, right? So you'll see the 25 and the 24 events. So 25 is user reconnecting. Now, in this case, they're reconnecting from a different IP address, which means there's a 24 event that happens showing their original session from, in this case, 192.168.1.10 being disconnected to make way for the reconnection from the new IP address. And by the way, I've seen the Windows event logs log the 24 and 25 events in either order. It just, there doesn't seem to be much rhyme or reason for which one gets thrown down in the logs first. So, but this is a typical pattern where you have, maybe multiple attackers using the same credential or the same attacker coming in through multiple systems. You'll see these, 1149 events, which may be paired with a normal, 21 style logon success, or they may be paired with these, reconnect, disconnect events, 24 and 25, in the local session manager logs. So both of those happen, and I've observed both of those in my actual cases. But in any event, we now have a sense, right? We can see, what credential they're using again, where they're connecting from, and again, we have time frames so we can, establish activity on the system within particular windows of time. So it's, it's a good amount of information. And if I had security logs, I mean, there would be a 4624 event associated with RDP logins. That's logon type 10, by the way. So normal network logins, like I showed you before, are logon type 3. RDP type logins are logon type 10. Okay, but in this case, because I'm on the domain controller, all of my 4624 events have been overwritten, so I don't see them. But on a less heavily used machine, you'd actually be able to tie the 4624 events to the 1149 and 21 events in the terminal services logs as well. Okay. But in this case, all I've got is the terminal services logs. But they go back quite far. I mean, even on domain controllers, I've seen terminal services logs go back for the better part of a year. So you have quite a bit of historical legacy stuff for terminal services kinds of things. Okay, so I've got all this stuff about attackers logging into the system, and that's all great, right? But I got some other sort of bonus things from looking at the event logs on this system, and they were related to the different persistence mechanisms for the malware that the attacker has established on this machine. So in particular, the attacker, well, actually, I'm going to do a little quiz here. So I was looking at the timeline of all of the different event logs that I'd thrown into a super timeline, and what I noticed was that every time there was a user login, I saw one of these logs. It was actually from the semantic endpoint protection client they had installed on these machines. So antivirus is dead, right? But sometimes the endpoint protection tools can show you useful stuff if you're paying attention. So this one was associated with every single user login on the box, whether it was by RDP or whatever. Okay, every time a user logged in, right after the login, we saw this little thing. We saw a tamper warning on servicehost.exe, and it was associated with the particular user login. So anybody have any theories about what the persistence mechanism was that was being used for this particular malware? Throw it in the chat if you want. Okay, persistence mechanism associated with user login usually means that there's a current version run key that's set. Okay, so that's typically what you're gonna see. Current version run keys can be set so that software is activated when a given user logs in, and that's exactly what happened here. We had a remote access Trojan where the persistence mechanism was current version run key that was set in the all users registry. So any user who logged in executed the attacker's malware. The program that was executed then injected the malware into a service host.exe process, which is why we're getting the tamper warning from the Symantec product. Okay. So this was noisy. I mean, this was all over the logs on this particular system, and every time somebody logged into the freaking domain controller, the attacker's malware got activated and was beaconing out. So it turns out, if this particular client had been paying attention to their firewall logs and things like that, they would have seen the beacons every single time somebody logged into the domain controller. But unfortunately, for them anyway, they weren't paying attention. So this one was a little bit subtle, but once I started looking at the other events and then noticed this one, I'm like, why is that happening? And then of course you can go off and do a little bit of memory analysis, run a malfind or something like that on the service host process, and sure enough, you see the injected memory segment with the rat floating around in it. So so this one was interesting. I mean, so there's a bunch of different application logs that may be created, and you don't ignore those because they have clues like this in them. If you're looking for them. This is again a case where putting all the logs together into something like a super timeline is definitely a useful investigative technique, because then you can see all of these things happening chronologically, and you start to see a pattern developing that can be useful for you. So turns out that there was another clue in a different event log related to the other remote access Trojan that they installed on this machine. So, I mentioned there were two different malware loaded on this box. So the other clue comes to us from the system event log, where in particular you see event ID 745, which is a service being registered, right? So another common persistence mechanism is to install your malware as a system service. And in the 7045 events, you'll see obviously the timestamp when the service was registered, but you'll see the service name that the service was registered. Again, I've changed the service name. And more importantly, you see the full path name to the executable that is being registered. So in this case, this one was really obvious because the attackers used a completely stupid directory path for their service, right? I mean, not a lot of services that run out of Windows temp. So that one was sort of obvious. And you see attackers, putting their malware in random directories. I mean, maybe a directory read under C:, or under program data, but outside of the normal system bin directories, right? I mean, normally I'd expect to see a service being run out of, I don't know, Windows System 32 maybe under, somewhere under program files if it's a third-party application. But Windows temp, forget it, right? I mean, obviously not good. So again, like if you're looking for things to kind of look for as far as automating your infrastructure and alerting, look for suspicious service event registrations. So it's event ID 745. Look for the image path, right? If the image path is something non-standard, or maybe even just like something you've never seen before, right? So this is a case where stacking across multiple systems would definitely be useful. So in this case, it's an alert. Hey, look, somebody's doing something kind of hinky here. So I've seen a lot of malware persistence via service in my investigations over the last 8 or 9 months. Seems to be a very popular mechanism these days. In this case, you can see, start type auto start means it's going to start whenever the system reboots. You can see what privileges it's running with, local system. So, I mean, they've owned the box at this point. So now you can go off and do your disk-based analysis, and you know where the malware is now. So go find it and give it to your malware analysts, and let them figure out what kind of Trojan you've got on the system. The other thing I'll say about this is attackers will sometimes get in and they'll trash your security event logs because they know there's bad stuff in there. But this is a case where they often will leave behind the system EVTX because they don't think there's anything particularly bad in there from their perspective. But I mean, here clearly we see a clear sign of the attacker's activity. So yeah. So with this second example, what I really wanted to show you was, first off, even when you don't have your security event log, whether it's because it's eaten its own tail so rapidly that the events you want are gone, or because the attacker has removed the security event log, there's still lots of other places that you can go to look for signs of attacker activity. If they're using RDP, the terminal services logs last a long time. They go back many months, and you can profile activity far back in time, right? And that's good because you can then sort of see the normal RDP activity into the system, so that when the attackers start RDPing into the box, it stands out like a sore thumb because they're using an account that you've never seen on the box before, or whatever. There are additional application logs, maybe from third-party applications like Symantec that we saw before, that may give you clues. Those are easier to spot if you put all of the logs into a timeline and kind of read them chronologically. And even the basic system event logs can contain useful things like showing the attacker registering the service for malware persistence, right? So don't give up just because you don't have security event logs. There's lots and lots of other logs that last longer or maybe more persistent. Okay, so that was a quick drive-by on the kinds of events that I've been using for my investigations recently. Are there any other questions people want to throw out at me before we close off for the day? There won't be a survey, by the way. Thankfully, it's just a webcast. There is my contact information again if you have any questions after the webcast is over, or you think of things later. Also, don't forget, I will be talking a lot more about intrusion response forensics in Baltimore in just a few weeks. So beginning of March, if you haven't signed up already, I hope to see you there. Okay, I'm going to throw it back to Trevor to close us out. Trevor, it's all yours.
All right. I would like to say thank you so much to our featured speaker, Hal, for his great presentation today and for bringing this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived webcasts, visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.